Hey guys, hope everyone is having a really nice day. Start off. Welcome to today's homework help. Just like the last couple of days, we're going to go over homework. Hopefully, I can give you some pointers that'll help you out with tonight's homework and it'll make it a little less stressful for you. So we're going to start off on the top. Just like the last couple of days, I've just given you a couple computation problems on the top. But today we're looking at division, and today we're looking a little more at dividing by a double-digit divisor. Now, the first thing I want to point out is that scares a lot of people, but it doesn't really change anything. We still use the same techniques that we use when we're dividing by a single digit divisor. Now, if we look at this first problem here, it says 11,574 divided by 18. So what we're doing is we're taking this first number and we're splitting it up into 18 groups. So we know then if we're splitting into 18 smaller groups, then our answer has to be much less than 11,574 because we're splitting that number up. So remember, whichever number we are dividing up always goes inside of our symbol here, 574. And whatever number we're dividing it into that number of groups, that's going to go on the outside of our symbol. Now we have, again, 11,574 divided by 18. Now, most of the time, I like to start off with my place value. So I'm going to put 10,000s, 1,000, 100, 10s, and 1s. I know that I have 5 place values there, so I want to put something in all of those, even if it's just a 0. That would be something. Now, when we're starting here, a lot of times what people like to do is write down multiples of this number. The difference here is you might not know multiples of 18. So I'm going to give you 2 strategies. Strategy number 1, and because you might not know how to count by your 18s, you could do that. You could say, well, your first multiple is obviously 18. To find the next one, you would do 18 plus 18, which is 36. To find the next one, you would add 18 to that, which is 54. And you could continue that process over and over. If I added another 18, that would be 72. And it's a good idea probably to label your multiples. This would be multiple 1, 2, 3, and 4, and so on. That's an easy way to find your multiples. Option number 2 actually deals a little bit less with finding multiples at all. And it deals with taking this number and looking at what numbers are close to 18 that are easy to count by. And for me, that number would be 20. It's really easy to count by 20, 40, 60, 80, 100. And we kind of use it as a guess and test point. And I'll show you how to do that in just a moment. Now, I'm starting off with 10,000, and I only have one 10,000. Because I only have one 10,000, I don't have enough to split up into all 18 groups. I'm going to put a 0 in the 10,000 place. Okay. I have 11,000s. Again, I have 18 groups. So I don't have enough thousands to split up into all of those groups. So I'm going to put a 0 there. Now, we get to the hundreds place. I have 115 hundreds. 115 hundreds. Now, again, I can either A, continue with my multiples by adding 18, adding 18, adding 18. That'll work. Or B, something that you can think about is think about a number that is close to 18. Like I said, for me is 20. So I'm going to count until I get close to 115 by 20s. So I'm going to say 20, 40, 60, 80, 100, 120. So 6 multiples of 18 gets me close to 115. So I'm going to go over to the side and I'm going to do a guess and test. I'm going to do 18 times 6. I'm going to see how close I get to this number, which gives me 108, which that worked because if I added another group of 18, that's going to give me more than 115 hundreds. So what I'm going to do is I'm going to put a 6 here. And I already know that 6 times 18 is 108. And then just like before, I'm going to subtract. 115 minus 108 is 7. And I'm going to bring down my 7 tens so that now I have 77 tens. This division works just like before. Like I said, it's really just about either A, finding your multiples, or B, finding a number that is close that we can count by, and then we can use a guess and test. Now, let's say we would have multiplied here and it was too big. I would just use the digit below. So I would have went to 18 times 5 to see if that worked. Now, we'll continue this down. 18, how many, we have 77 tens. We're splitting into 18 groups. I look over to my side. Notice I found a multiple that is really close to 77, which is 72. Again, you could have used my other strategy. We could have said 20, 40, 60, 80. Now we went over to the side and did 18 times 4, which is 72. So now that's going to be a 4. So I used 72 of my 10s. I have 5 left. And I have 4 ones. This process works just like it did when we had single digits, okay? So I'm going to let you finish off that problem. Let me erase this a little bit, and we'll take a look at the second problem here. All right. The second problem is really similar. We have 525, and we're dividing that up into 29 groups. Again, let's put our place value markers down. This time only going to the hundreds place. Hundreds, tens, ones. Just like before, option A, we can count by 29s by adding together 29 each time. Adding 29 again. And again, I like to label those multiples just so I have it there for later. That's an option. Option B, we can count by a number close to 29, which in this case for me would be 30. So we can count by 30, 60, 90, 120, and so on. So here I know that I have 29 and I have only 5 hundreds. So I don't have enough hundreds to split into every group. But I do have 52 tens. If I have 52 tens, that's enough to split into every group. If I'm counting by 30s, I would say 30, 60 would get me close to 52. I go to the side and do 29 times 2, which is 58, which is too big, which tells me I can only put 1 10 into each group. 1 10 into each group would be 29 tens, which would leave me with 23. Then I have 5 ones. Now, this is where we get into a little stickier situation because we have a really large number of ones that we're splitting across 29 groups. Now, we don't have enough to put 10 in every group because we only have 23 tens, but we do have enough to put some ones in every group. Again, your options, either continue counting by 29 or, again, what I would choose to do is to count by those 30. So 30, 60, 90, 120, 150, 180, 210, 240 gets me right around there. So again, I would go over to the side and try 29 times 8, see how close I get there, see if it works, see if I can get any closer. If it's too small, try 29 times 9. If it's too big, try 29 times 7. And that's a really good strategy to figure out double-digit division. So I want you guys to try that, and hopefully that helps you out with that a little bit. All right, let's move on to the second part of our first here. Okay. So the second part of our homework tonight gives us the following question. It says, Mr. Thompson recently found 847 pairs of socks. I like socks. He wants to put them into piles with 5 pairs in each pile. So I'm dividing them up into groups of 5. And he decided that he would need to divide 847 divided by 5, dividing it up to know how many piles to make. When he did, he calculated the solution would be 169 with a remainder of 2. So I'm giving you the solution. Now the question here is saying, what does that mean? What does this remainder mean? Well, think about what we're dividing up. The 847 is the number of sock pairs, which is important. The 5 tells us the number of pairs in each pile. I'm going to put pairs per pile. So the 169 is telling me the number of piles. Now, we know that there's 169 piles of 5s. So we have 169 piles of 5s. I want you to think about in this case, when we're talking about this remainder of 2, what is left over? And then once you know what is left over, what are we going to do with that? What are we going to do with that last 2? Do we leave it out? Do we make another group? I just want you to explain to me there, what can we do with that remainder because it's important? And then tell me how many total groups we have. Keep in mind that it's possible one of the groups might be a little different in size. So think about that as you're answering that question. All right, which brings us to the last question, and it says this. It says, Maciel and Genesis recently applied for jobs at Facebook, and they were both hired. After their idea to develop a "this status makes me want to dance" button was accepted, they were promoted to owners of the company. That is amazing. For every time a person clicks the button, they receive $12. So I'm going to write $12 per click. They get that every single time. Now, in the first minute that the button was live, they made $8,004 in first minute. And our question here is asking, how many times was the button clicked? Well, we know that they make $12 per click. And we know that they've made $8,000. We just don't know how many times it was clicked. So in my mind, the first thing that pops in my mind is I'm thinking, well, 12 times something must be 8,004. Now, if we take this and we work backwards, the question is, how could we go about finding what this something is? Remember, we have this idea of inverse operations. So think about the opposite operation. Think about how you could use it to go about solving this question to tell me the number of clicks. The other thing I want you to think about is what type of answer would make sense. Would it make sense that the number was bigger than 8,004? Or would it make sense that the number was smaller than 8,004 if we're talking about the number of clicks? So really give that a thought as you're working through this problem. I hope we helped a little bit tonight on homework. Again, let me know if you have any questions. Keep working hard, and I'll see you guys later.